Okay, here we go. So here is the course webpage for this class. And you should make a note of that because you'll need to go here a lot. CSUSBDT.github.io/201-2015-winter. So everything you need to do and everything you need to know about in terms of the schedule and what you need to do is here on the website. And I'll try to record the presentations that I give during lecture, and I'll post them here on this page here. So like today, I'm recording today. I can't guarantee the recording always works. It usually works, so I post these so you can review what we cover in lecture together by viewing the videos when they're finished. And here's the schedule of activities. There's 3 exams and 1 final exam. It's a total of 4 exams for the class. And there's seats down here. There's one there. There's one in the middle there. You might want to come around this way. Go in there. So there's exams. So you have to prepare for exams in this class. And the exams are taken in this room. You do it without the aid of notes, without the aid of a computer or a calculator, just a pen or pencil and paper, that's it. And so you take 4 exams. And then in addition to the exams, there's also these lab activities. And lab activities are actually more like assignments. You can do them in lab, but most likely you'll need to work on them outside of lab as general assignments. And what I've done is I've geared these assignments toward preparing for the exams. Is there a seat right there? There's a seat right there. You got to let this fellow through. So you can see there's L9. So L is for lab. Lab 1 through lab 9. And so those are graded. And the exams, E1, E2, E3, and final exam, those are also graded. And once again, the assignments are very much integrated in with what you need to do to prepare for the exams. And mainly this course is about learning how to write computer programs. So we're going to work in a specific language, a computer language called C++. There must be seats. When people raise your hands where there's an available seat, there's one in the middle here. There's one here. Look at the people raising hands. That's where there's seats. There's a seat down here. Plenty of seats. Well, no, there's not plenty of seats, actually. There's a shortage of seats. And there's a chair in the front here. If you take this and move it to the back, you can sit in the back. Right here in the front. You've got to move that to the back. There's a seat right there in the middle. Here, raise your hand again. Right there. See that fellow right there? It usually thins out after a couple of weeks, by the way, so it's really crowded right now. But somehow a bunch of people will drop and it thins out a bit. More people. A seat right there, I think, right? Take a seat there. Okay. So we're learning computer programming with the C++ language. It's an old language. It's an important language. A lot of code is written in C++. There's good job opportunities for people that know that language. And also, if you know that language, it's easy to learn other languages because, to be truthful, it's a difficult language. So it's a bit challenging. But because it's difficult, we're going to go slowly, and we won't cover all of the facets of the language that programmers use. We're just going to start with an introduction. And there's plenty to the language that we won't actually get to this quarter. So in the subsequent course, called 202, Introduction to Computer Science 2, that the rest of the language is covered. Are there any free seats? Can someone raise hands next to open seat? No, that's it, huh? Okay, well, you got to stand. Standing room only. So there is a syllabus. Let's go and take a look at that. Here's the prerequisite. Some exposure to programming. So if you're not sure that you have the background to succeed in the class, then you can talk to me, all right? And I'll try to assess your readiness to do well in the class. There are some people who don't have a programming background. Maybe they're pretty good at math, though, and they can get through the class without too much trouble. But if you're not good at math, or you're behind in math and you haven't had any programming background, then you might find this class to be overly challenging. So once again, if that's your case, you should talk to me about it, say after lecture today. So we have these lecture meetings twice a week. These are the times, as you know. There's 2 labs. The labs your attendance in the labs is optional. So you don't have, but you need to submit the materials. You need to submit your work for each lab. But that submission is done by email. And there's a textbook, and I follow the textbook, but I don't rely on it. So if you have an older edition of this book, it's okay. If you have a different textbook that covers the C++ language, it's probably okay as well. But the topics that are in this book, this course was based on using this book for many years. And I eventually developed my own exercises and lab activities and kind of detached myself from being dependent on this book. But it's hard to learn this material without a book, without some reference source other than the lectures. So you're probably going to need to think about what kind of documentation you need to access to learn about the material that we cover in this class. And this book is one way to do it. The class, once again, is based on this book. Here's my email. My name is David Turner. These are my office hours. And this is stuff I've already talked about. Learning objectives, learn about different things related to programming. Learn how to devise algorithms that solve computing problems. So that's a very general concern. It's not specific to the operating system you'll be using or the language that we're covering. This is a very general sort of learning objective. Learn about primitive data types. Well, this is a concept that's present in all computer languages. Well, yeah, almost all, I think. And once again, this is a general learning outcome that you should achieve, even though we're looking at a specific language. But what you're learning in this, working with this specific language, C++, can be applied in other language contexts, other programming languages. Learn about user-defined data types. I'm not going to explain what that is now. Flow control structures, constructs, functions, and so on. We'll get into those details when we get there. So this one here, learning objective, the last 2 learning objectives, how to compile code into executable files. That's pretty straightforward, that's simple. How to use the Linux command line interface. So that's one component of the class that it's not too tough, it's not overly cumbersome, but it's very valuable to learn how to use the command line interface of operating systems. And so we've chosen Linux. That's what we have installed in the labs. But if you're working at home, you're probably running Windows or OS 10. Those operating systems have a similar command line interface, especially OS 10. I'm running OS 10 here, as you can see. And the command line interface that I have in OS 10 operates essentially identical to the Linux command line interface. So all the commands you'll see me use at the command line, you can use in the lab on the Linux machines. Of course, you may be running Linux on your laptops or home computers, and then you can work in Linux, and that's a good exercise to try to work in Linux. It gives you that experience with another operating system. If you're used to, say, Windows, for instance, Linux would give you a better, it would give you exposure to an important platform that's used widely in the industry. So Linux-based machines are widely used for back-end things, like web services, websites, data centers, scientific computing. Those kinds of applications, those big things, tend to be done with Linux, not Windows or Mac OS 10. So learning Linux is beneficial. Let's see. So you're going to complete a sequence of assignments and labs. Actually, this is an old sentence that I need to change. You're going to complete a sequence of labs. So I called everything a lab. I used to have assignments and labs. They're numbered L1 through L9, and they're called labs. But they're really labs/assignments. And there are deadlines for those. You can see those on the schedule. You can work in any operating system to do these assignments. Windows is okay. You'll need a compiler if you're working at Windows. Right? So Visual Studio is the standard compiler. You can get that for free. It's called, what's it called? I forgot the name of it. What's the free version of Visual Studio for Windows? Anybody know?
Visual C++.
Visual C++. What's it called? The free version?
The basic?
Huh?
Basic, I think.
Basic? No, it's the, what's it called? Oh, Express. There we go. Here it is. I guess it's this one. So Visual Studio Express, it's not Visual Studio Professional. I wouldn't pay for Visual Studio Professional. It doesn't give you anything that you need for this class. Visual Studio Express is designed for students. It's free, and that's what you should use. There's a teaching assistant for this class, Jaron Willis. He's not here now, but he'll be in the lab. He works with Visual Studio, so he can, if you're having trouble with Visual Studio, you can go to Jaron Willis. He has a lot of experience using Visual Studio. And you can go to me as well. I know how to fix problems in that. They give you choices here. I got to say, Azure, that's like cloud computing, Visual Studio Online. This is new stuff. I'm not, didn't really want to do that, but I'm just going to give that up. Maybe that's what you want, this one here. So you're creating apps for desktops. So you're going to be creating apps for desktops, actually command line applications. So you're going to actually, for the labs, you're going to write programs, and then you're going to email the programs to Jaron Willis and CC me. Okay, so that's how you submit your work. You finish a program, it's a file or a group of files. In the beginning, it's just a single file. So actually each lab will be several programs. So maybe a lab might have 4 or 5 programming activities. So that means you'll have 4 or 5 files that you need to send by email to Jaron, Willis, and me. And then we'll evaluate your work. You don't send us the executables, the compiled result of the program. Just send us the source code. Maybe you don't know what source code. What's the difference between an executable and source code? Maybe some of you don't know that yet, but you'll know that before the end of the week. You'll understand what I'm talking about. So when you have source code is a set of instructions, like a word processing document. You know, you've got writing in a page. And so the program is like a document that has, in our case, C++ statements in it. And you want to turn that source code into a runnable program. So you send this source code through what's called a compiler, which is a program. And the compiler takes the source code, the C++ statements that you write, and translates it into a machine instructions, and which can be loaded by the operating system and run. So there's two things that you could get wrong in that process. The first thing is you could have syntax errors. You could type in statements in the language, C++ language, that are incorrect, that are meaningless, that the compiler doesn't understand what to do with. That's called a compilation error. So in that case, the compiler says, I give up, I can't produce an executable program from your source code because I don't understand your source code. It violates rules of the language, so I don't know how to process what you're giving me. So that's called a compilation error. If you submit any work with compilation errors, you get no credit. So at a minimum, your submitted work has to compile. It has to produce an executable file. After you produce an executable file from the source code, then you run it. And when you run it, then you could have runtime errors. It may not run correctly. You know, it may crash, or maybe it doesn't solve the problem that's stated in the exercise. So those are runtime errors. And so you need to remove the runtime errors in order to get full credit for your submitted work. Once again, if you submit late, then you'll lose all points or some of the points. So be careful about. Don't submit by the deadline. Try to submit early if you can. That's the safe way to do it. And you're not allowed to copy code from other people. You got to write the code yourself. If you copy code from someone else, then you're not going to learn how to do it. So you won't, that would be cheating, I guess. And you'll also do poorly in the exams. So a lot of the exercises that you'll be doing prepare you to do well in the exams. And the exams, by the way, are a good reflection of your knowledge and your mastery of the subject. And if you're going into programming as a line of work, that's something that you end up doing. And many of you will be programmers, at least half of you. We're going to deal with programs when you graduate. And you go in for a job interview. They might sit you down in a room with a pencil and paper, just like taking an exam in this class, and say, you know, write a program that, that searches for the number 7 in a singly linked list. And you just we'll give you an hour. Go ahead and try to write the procedures down that are needed to solve that problem. And they go away, and you're in the room. You don't have access to the internet. You don't have access to a book. It's just like taking an exam in this class. So this exam scenario that that you'll be going through in this class is actually practical experience for you, in the sense that you could be given a similar exam in the future after graduation to verify your ability to solve computing problems. Also, now, the other thing to keep in mind about writing programs, it's a lot like taking an English class, an English composition class. You can write down your ideas, but if someone else can't read them, it's not an effective document that you wrote. So similarly, you can actually make a program work to solve the stated problems. But if it's not readable by other people, if it's not readable by yourself 3 months later because it was poorly written, then that's a problem. That's a maintainability problem, because in industry, computer programs almost always change constantly. They're in constant flux. You know how your system is always updating all the time? It's always updating. Computer programs almost always are revised, are debugged, they're extended constantly. And so for that process to succeed, the code has to be readable, it has to be structured well, it has to be commented clearly, it has to be understandable to humans, not just understandable to the computer. And so here is a chart that describes the criteria, the readability criteria for this course. And so I've named the various criteria in this first column with some explanation here. Is the code well organized? That's organization. Cleanliness. Have unnecessary variables and logic been removed from the code? That's what I mean by cleanliness. Some people, while they're solving a problem, they'll say, well, we'll need a variable X. And you start coding, and an hour later, when you finally finish the program, it turns out you didn't need the variable X. You don't even use it, but it's still in your source code. It's declared, maybe it's initialized. There could even be an operation on it, but it has no bearing on the outcome of the program. That variable X should have been removed before the assignment is submitted. If you leave in junk, then it's much harder for other people to read your code and understand what it's doing. So I call that cleanliness. I have to pick a word for it. I call it cleanliness. Logical indentation. So in computer programs, you have statements. Say, computer, open a file. Read the first byte. Read the second byte. Close the file. Now, and so on. You have these instructions, these commands. And the computer is going to do them. And but some commands are subcommands. Well, let's call them statements. Some statements are substatements. For instance, if x is bigger than 1, then x equals 2 times x. So if x is bigger than 1, then I want to double what the value x is. That's called a conditional statement. So there's the statement, it's one single complex statement. If x is bigger than 1, then x equals x times 2. But inside this complex statement is a substatement, x equals x plus 2, x equals x times 2, whenever my example is there. So you've got substatements. And whenever you have a substatement like that, it needs to be indented, not for the compiler, but for the human who's reading your code. So indentation in computer programs shows the relationship between statements. It shows that one statement or several statements are substatements or component substatements of a larger parent statement. So indentation is very important, and you'll see as we go along, I'll be indenting my code. Please You'll need to pay attention to that. Also, the textbook, you can study the code that's in the textbook to see how that indentation is accomplished. So the indentation has to be logical. The indentation needs to express the true relationship between the statements, but it also needs to be consistent. So in one area, you're using 4 spaces for an indent. In another part of the program, you're using a tab for an indent. Well, that doesn't work because how many spaces are a tab? Well, I don't know, 8, 4, 2, whatever you set your editor for. So if you want to use tabs for indentation, you've got to use tabs everywhere. If you want to use, you can't mix tabs with spaces because the number of spaces for a tab is dependent on the editor that you're using to view the source code. I call that portable indentation. Consistent indentation means, well, if you're using 4 spaces to indent, use 4 spaces everywhere. Don't suddenly shift to 2 spaces. Logical spacing. So, I don't want to go too much more onto these because it won't make much sense to you right now. We'll come back and look at these as we get practice writing programs. And this set of criteria here, readability criteria, will make more sense to you. So right now, it's just abstract. You don't have any concrete experience, perhaps. Some of you may know what I'm talking about, and others who are new to this don't understand this yet. So I'm going to skip over the rest of these. But these are very important. So you need to read these and understand these. And this is the grading. So and by the way, I have a grade sheet. It's in here. And you'll get an ID, and you'll be able to see what grade that you have for the different labs and exams. And you'll be able to see where other people are at as well in the course. Okay, so you won't have your name up here, but we'll tell you what your ID is, your numeric ID. You'll be able to look up if you want to check to see what it is that I see, your progress in the course. Did they get my lab 4? Well, you go to this website, this web page, look up your ID and see, oh yeah, they recorded lab 4 for me, so I know that they got that. And at the end of the course, I just add them up and calculate the standard grading approach. And this is the breakdown right there. I have a section on learning outcomes. I thought I did that up here. Well, learning objectives. This stuff, we have to do lots of assessment of learning and all kinds of administrative paperwork that has to be done more and more every year. And so I had to tack this on and this is something we try to measure, these learning outcomes. We try to measure these, and this goes into a larger report that's used to evaluate the effectiveness of our program here. Students with disabilities, if you have a disability and you're concerned about something, then please talk to me about it and also read this paragraph. Oh, there's a fantastic resource here called the Computer Science and Engineering Club. This is a fantastic group of students. These are students that you could associate with. These are very serious students. Most students that are involved with the club do very well when they graduate. They all find good jobs. Excellent jobs. And so this, they do lots of tutoring, the club, lots of activities that engage everybody in computer science. So I highly recommend this. So check that out. All right, that's the syllabus. This is contact. This is me. This is Jaron. And I gotta check these times here. I think that's okay, but I carried this over from last quarter. This is probably good. These extra lab hours. I gotta check with him about that, so I might change that. If you want to work with Jaron, then you should talk to him. Okay, just talk to Jaron. He'll be in lab. And let's see, we'll go back to the schedule here. Let's dive right in and look at lab 1. It's called, the name of the lab is Command Line. Deadline is January 16. It's 4 days. And so for this, you need to have a lab account. And so you'll need to show up for lab, at least the first lab, to get this lab account. And so you'll get a username and password. And the first thing you should do is change your password. By the way, you can work on a lab machine remotely. You can work on a lab machine from home or right here sitting in class. So you just use what's called Secure Shell. There's this command line utility called Secure Shell. And just pick a random machine in the lab and log into it. It doesn't matter if someone else is working on it or not. You can still work on it. And I'll illustrate that for you today. Oh, here's a link on how to do that. How to work remotely using SSH. If you're on Windows, you need to install something like PuTTY. If you're on Mac, you've already got SSH built into your machine. Or if you're using Linux, same thing. So on my Mac, I already have SSH installed. And the whole explanation on how to do that is here. You can practice that in the lab as well. So the first lab, you're learning Linux, the Linux command line. Well, you don't have to work in Linux for the whole course. You know, you could work on Windows if you like, for instance. But you should work at the, well, not should. You can work at the command line. So you run, let me show you what the command line looks like. Here's the terminal window right there. Well, this is what I mean by the command line. I had that, I'll type in exit to exit. Of course, I could also close it here. But when I type in exit, it feels like a cleaner way to kill the session. But if you go to applications, under utilities and terminal, that's the same thing. That's how you get there on a Mac. And on Windows, you're going to look for it. You know, it's I think, what do they call it? The console program or the terminal program? One of those two. And the commands are not identical. They're similar on Windows. But Linux and Mac are identical. Because Linux and OS X are both based on Unix. So Unix is like the parent, grandparent operating system that Linux and OS X grew out of. So this thing here is called a prompt. This is some information. And if I can type in commands like this, clear, so that clears the screen. But at a minimum, I get what's called a prompt. So a prompt is just a symbol. It has some information in it. You can customize your prompt. I customized mine so it was as small as possible. Well, not as small as possible. So it has the information that I want in it. Basically, it has This $ means I'm a regular user, not a root user. And this tilde means I'm in my home directory. So that's information that I'm looking at that I understand. Tilde means your home directory on Linux and Mac. On Windows, I don't think tilde represents home directory. And you do things. This is the command line. I can change directory. So you've got basically what you're looking at, your system. So you've got RAM running, right? So you have your processor with RAM. You're running programs like the terminal windows are running program. The program has been loaded into RAM and is running along with other programs. So it's a multitasking environment. So lots of things are happening at the same time. Well, lots of things are happening with the appearance of being at the same time. Well, actually, for multi-core processors, they do happen at the same time. So you've got RAM, and you've got programs that are loaded into RAM that are running. But where did the programs get loaded from? They get loaded from your persistent storage media, your hard drive. In my case, I got solid state memory, so it's like, they call it flash memory. And in that persistent memory store, you have something called a file system. And the file systems are containers of files and directories, or files and folders. So you've got the top level folder, and in a particular, say, drive, like on Windows, you have drives. On Linux and Mac, you just have a single file system. And it gives you even though you might have different drives, they're all merged together and presented to you as a user as one unified single file system. In Windows, it's a little different. Each drive has its own file system. It's presented to you as separate file systems. But these file systems they all have a root level. And inside this root, it's called a container. It's called a folder, a root folder, or the root directory. The word directory and folder is the same thing. And you've got this root folder, and in the root folder, you have other folders, subfolders, in files. And those subfolders have folders and files, and so on. So they call this a hierarchy. So it's a hierarchy of files and folders. And when you're running in this terminal window, and when you're running in another program as well, there's this concept that the operating system has of your current location in the file system. So a running program, has attached to it some notion of a current location in the file system. So the terminal window here, which is a running program, displays information to me about my current location in the file system. That's what that tilde is. And I can run this command, print a working directory. Oh, is that big enough? Can everyone see that? Is that big enough? I'm gonna make that a little bigger. PWD, print working directory. It's a very old command, by the way. It's a Unix command. So slashes are used to show the difference between folders. The leading slash means that this path starts from the root folder. Under the root folder is a folder called users. In the users folder is a folder called Turner. That's the location. That's my current directory, the current working directory, print working directory. Windows has the same notion. I think Windows uses PWD. Does it? Does Windows use PWD? Anybody running Windows right now can verify that? Excellent. And you're welcome to work in lecture, by the way. Bring in your laptops and have access to it. Are you running Windows?
Yeah.
Does PWD say anything?
Not recognized.
Doesn't do anything? I used to have an equivalency chart here. Let me see. I don't anymore. Where am I here? I'm here. So now I can see, all right, so I can move around. I can do, CD ... That means change my directory to the parent folder. You see how my prompt changed? Now it says users, because the prompt shows the name of the current folder. So I run pwd again. It shows that I'm in this users folder. And if I CD ... Again, I'm going to go to the parent of the users folder. You see the slash in my prompt? So I'm in the root folder right now. So pwd just shows me a slash. So CD is a way, and that works on Windows. CD works on Windows. This is a way to move around, is to change your current working directory. Then you can use the command ls to see what's in the folder. And ls takes arguments. You can do ls minus l, and that means a long list. Or ls minus a, that means show hidden files and folders, the things which on Linux and Unix means they start with a dot. On Windows, they have a different way of creating hidden files and folders. So once again, I can CD into users. See how my prompt changed? Now it shows I'm in users. pwd shows me I'm in users. What if I did CD users again? What's going to happen? Well, notice here, I didn't go slash users. That's called an absolute path. It says start at the root, and then in the root, look at the front of the folder called users. I'm saying, no, don't start in the root. Start with where you are now. And look and CD into the users folder. Well, I'm already in the users folder. So is there a users folder in the users folder? No, there isn't. So this should fail. No such file or directory. So I can't CD into a users folder within the users folder. No such thing. But I can CD into a folder called Turner, because that's my home directory. I know that exists. See that? And it just shows me tilde instead of slash users Turner, instead of Turner, just to tell me that it's a special case. It's my home directory. What happens if I do this? Is that going to work? No, Turner is not in the root. Turner is under users. And let's see, I can go to the root there, CD slash, I'm in the root folder. Now I'll show you a shortcut to get to my home directory. Just CD without any argument. By the way, this is an argument. When I do this, this is CD takes an argument. So it's the name of the folder to change into. But CD without an argument has behavior. Its default behavior is to do what? Anybody know? It's to go home. I'm in my home folder. That's the same on Windows, I think. CD by itself goes into your home, right? You check that? That works. So these are the commands that you need to get used to. Here, you're learning the command line interface. Here are the commands that are required for this class that you need to understand and can use. pwd, print working directory. cd, change directory. ls, list directory contents. mkdir, make a directory. rmdir, remove a directory. mv, move something. You can move a folder, move files. cp is copy, rm is remove. Remove is the same as delete, to delete something. And then you have three special symbols that you need to learn about. Dot, which designates the current directory. Dot dot, which designates the parent of the current directory, or the parent of some directory. And tilde, which is the home directory. And if you're on Windows and you have an account in the labs, then you can use Secure Shell. Or if you're on your laptop, you can use Secure Shell, whether you're in Windows or Mac or Linux. I'm going to show that to you. So it's SSH. Let's go and check the instructions on this. How to work remotely. So this is the computer that you need to connect to, because the lab machines are not directly on the internet. They have to pass through this intermediate computer to get there. And you use the SSH command like this. On Windows, it's different. On Windows, if you're using PuTTY, you could configure it to work like this, but you can use the command, the visual, the GUI, the graphical user interface version of PuTTY. So you would just enter this into a text box. So Windows is a little different, but on Mac and Linux, it's the same. This is what the command looks like. SSH, secure shell. Then you have to give your username, and for you, it'll be your student IDs. And JBH3-1, that's the host name, .csc, .csusb.edu. Now that's an internet domain name. So, this is like, it's like a postal address. This is like the country, edu. This is like the state. This is like the city. And this is like the street or the house. So this is how to get to this is using a domain name system to get the IP address of a computer that's on the internet. So you'll see this in your browser, when you browse the websites, you'll see something like that. It's part of the link or the URL. That's an address, an internet domain name address. Now, for you, I have it set up so I just log in automatically, but for you, it'll ask for a password. It'll also ask, it won't recognize the host you're connecting to, and it says, do you want to accept this host? And it could be a man-in-the-middle attack, which would compromise what you're doing. But since we're not dealing with things that are too sensitive, we're not FBI agents, so we can probably accept the public key of the host the first time we connect to it. So the first time you connect to the system, and you give the okay, the go ahead to cache what's called the public key credential. It'll cache it locally, and the next time you connect to the system, you won't be asked that question again. So it's something you can store away. Now here, we're on this intermediate computer. We need to log into a computer that's in the lab. The lab is 359, JB 359. And the computers are labeled 1 through 30. So let's log into computer number 29. Actually, this is optional because it's on the same network. So we only need that part. So the SSH program says, oh, you didn't give me a fully qualified domain name, so I'll assume that this is a host on your local network. That one's not working. New works. Did you notice he didn't type stars when I typed my password in there? It's more secure not to type stars. Because then someone looking at you they don't know how many characters you type in. Something like that. So just be aware that when you're typing in your password, you won't see stars like that. It'll be just quiet. So now I'm on this machine, and if I type users, I see that I'm the only user on the machine. And I exit from the machine. And I can exit from the intermediate machine. Now I'm on my local machine again. Now I'm back here. So you can use SSH to log into a lab machine and do the Lab 1 exercises. Or all the programming assignments in this class can be done using the secure shell. But I want to warn you that sometimes the network is not reliable. And so it's better to work locally on your machines. So if you have a Mac, you should install Xcode. Your Windows, you should install, what is it again? Visual Studio Express. Now, if you're on Linux, you should install the GNU compiler. And depending on the version, on the distribution of Linux you're using, you'll use this command or that command to do that. Test to see if it's there first. You know, you do something like run C++, it should clang, right? So it should show error, no input file. If it says command not found, then you have to install it. All right. If you're on Windows, you could use something like VirtualBox or other virtualization system to run an instance of Linux within your Windows system. Or you can do dual booting. That's the other way to do it. Or use SSH. That's another way to do it. Or just work on Windows and forget about Linux. You've got a lot of options on how you want to work. And actually, if you're a computer science major, you should learn how to do all of those things. You should learn how to compile programs on Windows, learn how to compile programs on Linux. If you can get access to a Mac, learn how a Mac works. Learn the graphical user interface, learn the command line interface. Then when you graduate, you're going to be more employable. So the more you learn, the broader your skill set, the stronger you'll be when you're in the job market. So we're going to write programs using a text editor. So that's the first thing you need to figure out is how to use a text editor on the system you're working on. And before I talk about that, I'm going to do a few more of these commands here. I'm going to make a directory, that clears the screen. mkdir 201. I'm going to make a directory called 201 in my home folder. Doesn't show you anything, does it? If I do ls, it'll show stuff. So I can cd into 201, and then it shows my path to my current folder here. So 201 is now a folder inside my home directory. And then you've got this move command, copy command, and so on. There's lots of different ways to, let's create a program now. And then we'll come back to these other commands. Here's the program right here that we're going to, this is already written. We're just going to compile it. This is the program. This has to be in a file, and the exercise calls for a file with the name hello.cpp. The extension .cpp means C++ source code. So the program, it just prints the word hello in the terminal window. That's all it does. And once you create this file with that source code in it, then you run this command line program, C++, runs the compiler, and you specify as its argument the file hello.cpp. So the C++ program will open that file, read its contents, and translate them into machine instructions, into an executable file, which it saves in the operating system. Saves the file, the default name of the file in Unix systems is a.out. Windows is something else, a.exe, I think. And this is how you run it. Now, when you run it, you have to use dot here because you need to tell the system to look in your current directory to find the executable a.out. So if you just type in a.out, it may not run. It could run. If the current directory is part of your system path, it'll run. But in general, current directory is not a part of the system path. So when you want to launch an executable file from the command line, you have to tell the terminal which folder to look in to find the file. Here we're telling the terminal program, hey, look in the current folder, current working directory. Look there, that's what the dot means. And the slash separates the folder name, or dot, the folder designator, from the file name. All right, let's go back to here. So the problem now is basically that we have to create a text file with this contents in it. I'm going to use a very old program called VI, which you're welcome to learn if you want to use it. If you want to be a system administrator, it's good to know how to use VI. But it's not a program that people generally work in when they write programs. Normally, programmers would use something like Visual Studio or Xcode on the Mac. I'm going to use VI, like Visual Editor, something like that. Hello.cpp. I'm in the editor. I'm going to press I to go into insert mode. I'm going to paste from my clipboard. And I'm going to follow a different style. This style, which puts the bracket right there, is a style that I followed in the past. And sometimes but this quarter I'm going to follow this style. I'm going to put the bracket, opening bracket on the same line that the statement starts on. So I pasted that in there. I press colon to bring up the command prompt. I'm going to press W and then enter return key. That writes the file. So it shows me the name of the file that just got written. I'm going to bring up the command prompt again, colon, and then issue a quit command. It's just the letter Q, enter. If I do ls, give me the contents of the folder, I see that the file is there. I can use that compiler command. I'm going to say compiler, C++. Clang, that's the name of the Macintosh compiler. It says no input files. Oh, let's give it an input file. Hello.cpp. That's the input file. And look at that. See that quietness there? It didn't say anything. That means it succeeded. If I do ls, there it is. A.out has been generated. That's the executable. Now let's run it. Once again, A.out, it was not going to run. Command not found. The system, the terminal window searches through the system path to find A.out. But A.out does not appear as a file in any of the folders in my system path. I'll show you what my system path looks like. That's a system path. This is a folder. It looks there. Is A dot out there? No. And there's a colon. That's a separator in this system path declaration. Then it's going to look in here. That's the next, and I highlighted that exactly. Then the terminal program is going to say, all right, let me look there. Oh, A dot out is not there. And it looks through this whole list of folders. It doesn't find A dot out. So it says, by the way, the name of the terminal window is called bash, the one I'm using. There's other terminal windows, they have other names. So the bash shell, sometimes it's said like that, is giving us the message. A dot out, command not found. It searched through my system path, did not find that file. So what we need to do is put a dot slash in front of it. And see it prints hello. So now it runs. Remember, the purpose of the program is just to print hello. We could also do this. We could also give the full path name to A dot out. See that? Under users is a folder called Turner. Under Turner is a folder called 201. In that folder is a file A dot out, and I'm going to just run that like that. So, but it's easier to do this, right? Dot slash. But if I went up a folder, if I went into my home directory, see, then dot A dot out, actually this might run. No, it doesn't run. A dot out is not in my current directory. It's in the 201 folder. So I'm going to give a, specify its location using a relative path. So an absolute path, this is an absolute path when I do this. So a relative path looks like this. It says start in my current directory. In my current directory is a subfolder called 201. In 201 is a file called A.out. Run that. See that? That's called a relative path. This is an absolute path. You know, or this one. So this form of the path will run everywhere. It doesn't matter where my current directory is, that'll run. This form of the path will only run in my current directories in the home folder. I'll use dot. Similarly, this path will only run if I'm currently in my home directory. I'm not sure if this is called an absolute path. Is that an absolute path? Maybe that's also a relative path, actually. That's probably called that's a relative path. So I'm going to correct myself on that. We could do this, watch. We could say, in my home folder, tilde means home folder. Under tilde is a folder called Turner, not Turner, I'm sorry, 201. And then A.out is inside 201. I can run it that way. So that's an absolute path, because tilde represents the home directory, whereas dot represents the current folder. So that's still sort of relative to the current location. This is not relative to the current location. It's relative to the logged in users, because this is the working directory of the logged in user. If you log in as someone else or log in as root, this will not run. However, this will run for all users. This is the cleanest, most complete absolute path you can use. This will run for if you're logged in as a different user, assuming you have permission to run that program as a different user, which you would if you are root. Okay. I dumped a lot of stuff on everybody, right? That's kind of it. I mean, there's a few things I didn't cover yet. I didn't talk about copy and remove, and maybe another text editor, Pico. I think Pico, you could use Pico is a little simpler to use than VI. Now, VI and Pico you can use in the SSH command. When you're using SSH from home, you got to use a character-based text editor like Pico or PI or Nano. You can't use gedit. In the labs, there's a graphical program called gedit which you could use. You can't run gedit from home, from a remote location, because it needs a graphical window, and that you're only going to get locally. So if you use this Pico or Nano, I'm not sure on the system whether they have Pico or Nano. Or maybe they have both. I copy that, paste that in there, and then down here, you only need to know a few of these. This angle here, that symbol right there, that's control. So I do Control O to write out. The name of the file to write, by.cpp. I'll write it there. Actually, let's change this. And I can use the back, the delete key, just like this. I don't have to go into edit mode like I do in VI. And I'm going to write it out. Control O, write out. And then Control X. You only need to know Control O and Control X. That's all you need. Or VI, you're going to know more. So now you'll see there's, oops. Oh, look, I put by.cpp in my home directory. I don't want it there. Let me move it. Let me move it into the 201 folder. So I use the mv command. Mv takes two arguments, source, destination. I want to move by.cpp into the 201 folder. I'm going to cd into 201. And ls, you see by.cpp is now in the 201 folder. And we can compile that. We can run that. Now it says by. Maybe I want to save a.out. I want to move a.out. Actually, move is also used for renaming a file. And I'll call it just by. There's by. Now I'm going to run by. It says by. If I move by to hello, what's it going to print? It's a quiz question. What's it going to print? I know I'm moving really fast. Huh? It's the same executable. I just renamed it to a different file name, right? Okay. And but I want the hello program. If I go -O, by the way, I can tell it what file name it generates. So it didn't generate a.out, it generated by. So what's that going to print? It's like, I got 3 nuts, and which, I do this, which ball is the nut on there? I mean, which nut is the ball under? So once again, you need to learn these commands. mv, also remove, I'm going to delete by, I'm going to delete hello. Those are gone. These are the commands you need to know. I think we pretty much covered everything. Oh, remove directory. I mean, that's, if you make a directory called SAM, I'm going to copy hello into SAM. Also, the copy is another command. See, SAM is a subdirectory. If I use ls -l, it's a long, it shows this little D right there in the permissions. That means SAM is a directory. So if I cd, so it's inside, I do ls SAM, it shows me the contents of SAM. Now if I try to remove SAM, I can't do it because it's not empty. So you need to remove a directory, you need to make it empty. So let's remove the file, and then I can remove the directory SAM. So that's it. I just gave you everything actually you need for the first lab. That's the whole thing. But you do need to practice with these commands to learn them. And the other thing we didn't do is we did not talk about this program. Why does that print hello? what's going on in that code. So we don't have time to do that today. Any questions? That's all I'm going to cover at this point. Is there any questions about anything? All right, I'll see some of you in lab today then.